Hey, what's up, y'all? I'm back after the new year. We've got a great question from a Reddit user. I don't know why I'm laughing. idkwhyimlaughing. And I think that there's actually no solution to this, but that's just my gut. I haven't worked it. I'm doing it live. So it says if x, y, and z represent three positive integers, such that the ratio of x to y to z is equal to 5 to 4 to 3, and x plus y plus z is equal to 10, find x, y, and z. Okay, so I'm fairly certain that this has no solutions. So since it doesn't appear to have solutions, I'm just going to brute force it because I don't think there are that many cases to check before we'll realize. So let's let x, y, and z be positive integers such that x to y to z is equal to 5 to 4 to 3. And x plus y plus z equals 10. Okay, so now suppose so z is the smallest, so let's suppose z equals 1. Okay, that would mean y over z equals 4 over 3, but we'll just replace, let me bring up my eraser, sorry. We will replace this z here with 1. So the ratio of y to z, which we've chosen z equal to 1, is 4 to 3. So we would cross multiply and we would get y, or actually we don't even need to cross multiply, y equals 4/3. Okay, right, you can see this is just over 1, so anything over 1 is just itself. And so here 4/3 is not an integer. So we chose it to be an integer there. So this gives us a contradiction, which I think they write that like this. Oops. Something like that. So contradiction. So z cannot be 1, okay? So similarly, suppose z equals 2. All right, that should be an underline, not a cross through, which was way more dramatic. Okay, so let's suppose that z equals 2. Okay, and let's do the same trick. Y over 2 equals 4/3. So we'll multiply by 2, and then we get y equals 8/3. But this is also not an integer, so we can't use that. So this should be the first case, z equals 3, where we can get an integer out of this. So let's suppose z equals 3 now, okay? So y over 3, which is y over z, is equal to 4 over 3, okay? And we multiply both sides by 3, which gets us y equal to 4. Okay, cool, we've got an integer. Now let's do the same thing. Let's do this for z, or let's do this for x. So x over 3 equals 5 over 3. Multiply both sides by 3, and we get x equal to 5. So here we have z equals 3, y equals 4, x equals 5. So let's sum those. We get 3 plus 4 plus 5. And is this equal to 10? No. This is not. So this is 12, which is not equal to 10. And it can be shown that, we could do a proof by induction and take forever and show that any one of these integer ratios, because this is the lowest integer ratio that worked, right? We did the first three. So we could show that any integer ratio that it satisfies the condition of the 5 to 4 to 3 is actually going to be bigger than this one. And this is the smallest sum since they're all positive. We can't use any negative numbers. So there's no solution to this problem as posed by the user. And I'm not sure where they got this from. Maybe they copied it down correctly, and one of those should have been a subtraction instead of an addition. That's entirely possible, in which case there would be a potential solution. I'm pretty sure there would be a solution. But sometimes, these come out of books or from a packet or something like that, and the teacher just hasn't vetted the problem, hasn't checked to see if it has a solution, and it doesn't have a solution. And I'm seeing more and more and more and more of that, especially as we're getting a lot more technology involved in the grading and assignment process. And they're taking more steps to prevent people from cheating, right? From finding the answers, which makes us have to use problems that haven't been done as many times. We don't want to be able to go look the answers up. So, sorry that you had this problem. The reason why you were stumped is because you probably correctly realized that there was no solution.